some conversion from octal to binary. Let's write this one right here, octal to binary. Let's look at the first example. Let's say I have a number that is 56 and the base is 8. I want to convert this one into binary. Now in order to convert an octal number to binary, we can use this one, like 4 to 1. You may ask, how did I get this 4 to 1? If you look at 2 powers, 2 power 0 is 1, 2 power 1 is 2, right? And then 2 power 2 is 4. So you can see 2 power 2 is 4 here, and then 2 power 1 is here, that is 2, and then 2 power 0 is 1. That's how I got 4 to 1. It's only useful to convert this one to binary. Here we are dealing with binary, so we can use this. And what about 2 power 3? What happens if I put 2 power 3 and if I have 8 here? What happens? The reason I cannot go after this is because if you add them together, it will give 7. Like for an octal number, the maximum number you can have is 7. It goes from 0 and up to 7. Like if you look at any number system, it's always 1 less than the base. If you look at decimal, the base is 10, but the maximum number we can have is 9. If you look at binary, the base is 2. The maximum number we can have is 1. If you look at hexadecimal, the base is 16. The maximum number we can have is 15. Like that, for octal, the maximum number we can have is 7. And if you go for this one, you can apply for hexadecimal. If you add them together, you get 15. 8, 4, 12, 12 plus 2, that's 14, and 14 plus 1, 15. You can apply this one for hexadecimal. But here we are dealing with octal, so the maximum number we can have is 7. That's why we are using 4 to 1. Okay, so after we got this 4 to 1 idea, once you have got this idea, then it's so easy. What you do is you grab each number. Like let's look at the first number. The first number is 5, right? So I take the 4 to 1, and if I add, is 5 exit by itself? No. So we have to add some numbers. If we add which numbers, that gives me 5. If I add this 4 and then 1, that gives me 5. So I have to put just 1 for those two values, and the others are 0. So this is 1, 0, 1. And if I take 6 and then 4 to 1, if I add which two numbers, that give me 6, 4 and 2. So that is 1, 1, 0. And when we combine them together, 1, 0, 1, 1, 1, 0, and that's our binary number for the given octal number. Now let's look at the next example. I'm going to go ahead and erase this one. Okay. Let's say we have a number given like this. 35 base 8. Again, take the 4 to 1, write the given number. First number is 3, and then I look at if I add which two number, that give me 4 to 1, or which 3 number, or which one number. Does it exist by itself? Here we had to add these two numbers to get 3. So 2 and 1, right? So whatever the number we are adding, we put 1 for that, and the others are 0. So this is 0, 0, 1. And then for 5, if I add which two number, that give me 5. 4 and 1, if I add them, it gives me 5. So I put 1 for them, and the others are 0. So the conversion for this one from octal to binary is 0, 1, 1, 1, 1, 0, 1. And whenever you get an answer like this, if you have a 0 on the left side, you can always remove it. Like, when you have 0, 5, the 0 is unnecessary. We can just write 5 like that. In binary numbers, if you have 0 in front, we can just remove it, and we can write it as 1, 1, 1, 0, 1. So the answer for this one is 1, 1, 1, 0, 1, and this space 2. Okay, now we can also verify whether we did it right by converting into decimal and then finding if we are getting the same value. Now to convert this one into a decimal number, what we do, we look at the weight for each number. The first number always carries the weight of 2 powers. I mean, if it's octal, it carries the weight of 8 power 0. And the second number carries the weight of 8 power 1. After that, what we do, we multiply by the weight. 8 power 1 times 3, and then plus 8 power 0 times 5. 8 times 3 is 24, plus 8 power 0 is 1. 1 times 5, that gives me 5. So this is going to be 24 plus 5, that is equal to 29. So this is base 10. Okay, now how can I see if it give me this value? Again, you convert, this is the final answer we got. You convert this one into a decimal as well, and see if you are getting 29. So to convert this one, I use a different color. Okay, this carries the weight of 2 power 0, this carries the weight of 2 power 1, this carries the weight of 2 power 2, this carries the weight of 2 power 3, and then this carries the weight of 2 power 4. And whenever we have a 0, we can neglect that one, because if you multiply 2 power 1 times 0, that's give me 0. So we don't want this. We can just multiply and add others together. So that's everything multiply 1, so it's going to be itself. So I'm going to be just writing the powers. 2 power 4 plus 2 power 3 plus 2 power 2 plus 2 power 0. 2 power 4 is 16. 2 power 3 is 8. 2 power 2 is 4. 2 power 0 is 1. And if you add them together, 16 plus 8 is 24. 24 plus 4 is 28. 28 plus 1 is 29. Again, we are getting the base 10. So you can see, when we convert to octal to decimal, octal to decimal, we got the 29, right? Octal to decimal, and then octal binary decimal. So there are two ways you can go for it. When we do both way, we are getting the 29. So the answer is right. And that's it for this video, guys. Thanks for watching. See you guys on my next video.